Hello, everybody. This is Oriette Nayel, Principal Project Executive at IBM. And today in this webinar, together with my colleague Guncha Malik, Executive Security Architect at IBM, and David McKee, CTO for Slingshot Simulations, we are going to talk about dark data, its origins, impact, and transformation. The content for the first part of the webinar is based on a paper co-authored by a team of SMEs and members of the Responsible Computing Object Management Group. In this part, Guncha and I will go over the significance of data in digital transformation, most popular origins of dark data, the impact of data in terms of trust, accuracy of analytics, maintenance, storage, and potential effect on organizational sustainability goals. And we will conclude with prevention and transformation ideas to support organizations, eliminate dark data and use it to their advantage. The aim is to help organizations develop deeper understanding and opt for optimal decisions to support their business and sustainability goals. So let us start. We start by defining dark data. Gartner defines dark data as the set of information assets organizations collect, process, and store during regular business activities, but generally fail to use for other purposes. Data could have been left behind from completed projects, from modified processes, inactive databases, or even organization restructuring. And organizations often retain these assets for compliance purposes only, or maybe use them once and then file and forget, which incurs more expenses and risk than value. So dark data is hidden information that takes huge amount of space in data centers, generate greenhouse gas emissions, and in some cases leads to incorrect conclusions, poor decisions, and of course, negative actions and consequences. Now, when we talk about data and its effect or the power of data in digital transformation, first we define what digital transformation is. In simple terms, digital transformation is maintaining competitive edge and better business through the continuous management of a customer experience. Or in more professional terms, we define digital transformation as a journey of continuous improvement of business processes and organizational culture to transform the customer experience while using technology as an enabler. And in doing so, digital transformation relies heavily on data and on analytics to continuously challenge the status quo, to identify new opportunities, and transform business process workflows and align with evolving customer needs and interests. So successful digital transformation depends on how an organization restructures itself, its processes, and its human capital to unlock value from data. So data is always significant in digital transformation. Before we talk about dark data and the origins of dark data, we need to talk first about the different data sources, the different data formats and characteristics. So first, the data can originate from the most popular sources of data could be from survey data that are gathered from a group of people about certain topic of research, maybe transaction data gathered at the point of sale involving selling and or buying. It could be sensor data gathered by device from physical environment, location data, which includes information about geographic positions of objects like devices, cities, buildings, roads, and so on. It could be also originating from social media gathered from digital posts across social media platforms. And of course, it could be from synthetic origins, which mainly are computer-generated information through machine learning algorithms. The data could be in three different formats, either structured, unstructured, or semi-structured. If it's structured, it can be represented in rows and columns as tabular data. They have predefined formats and can be easily collected, accessed, organized, and processed. Like survey data, for example, transaction data, sensor data, location data, they all have structured formats. An unstructured format doesn't have any predefined structure, and it could be represented by text, image, audio, video, and this is almost 80% of business data. We can also classify a format that is semi-structured, which can have some structure to it, but may not have that consistently implemented across all data. And we can find examples for this that could be XML, JSON, or HTML files. When data becomes large and complex, beyond the ability of traditional databases to access and process it with low latency, then we refer to this kind of data as big data. And we use AI and analytics to extract insights from big data. Big data is characterized by volume, variety, and velocity. And by volume, we mean the amount of data that is needed for storage and access, given the capacity constraints of the current data infrastructure that we have. The data variety include the different formats of data and how we can consolidate them together into a single system that can be accessed, processed, and utilized. And the third characteristic is the data velocity, which refers to the speed at which data is generated, distributed, collected, and processed, as well as the infrastructure needed to handle the storage, the real-time processing, and analysis of data that is continuously being generated. Now that we talked about the data sources, formats, and characteristics, we may turn to the different types of dark data. There are so many types of dark data, but we have selected the most popular types to talk about in this webinar and in the paper. First, we talk about the protected data. And this is non-hidden data, but cannot be used due to various reasons, like, for example, government regulations, organization policies, contractual commitments, and others. Examples could be customer information in banks, could be patient information in hospitals, where the records cannot be used for fear of misuse, bias, or even GDPR. So valuable data gets recorded and is out in the dark for the right reasons. However, it is useless for any decision-making, except for limited use by government and maybe regulated research. Obviously, the resource consumption to collect, store, and secure from misuse is a drain and contributes a lot to the computing carbon emissions. The next type of dark data we are going to talk about is the expired data, which was once relevant, but as time passes, it becomes idle and becomes like a depreciating asset. The longer they remain, the less value they have. Examples could be weather data, could be stock market data, and other examples. So expired data could evolve from data that was once correct once upon a time, with no relevant updates made for some time, or updates that are not reflected across all repositories or replicas of the application or solution. It does not represent the truth. It only adds carbon emissions and impairs trust and reliability of the solutions that are based on this kind of data. Then we go to unlabeled data, where we find that a lot of organizations, they possess massive amounts of data that is not properly labeled or lack identifiable schema. Without metadata on the lineage, on the ownership, the revision history, the semantics of the data elements, data may look just like a collection of numbers in alphabets, which is a waste of space, of course, and of processing power. When we come to the incomplete data, we are referring to data that could have missing values for specific columns in data records, or for a particular date, or country, or region, or even a branch office, or for specific employees in an HR database, products in the product profiles database. So it's a headache in analysis, and inside generation, this could make a total record useless. Then we go to the incorrect data, which simply results from incorrect numbers, typos, transposed letters, cut and paste errors, etc. The most challenging part here in the incorrect data is the detecting of the incorrectness, which often gets overlooked. We can also find improperly represented or formatted data, which is in unrecognizable formats. This is another big issue in wasted resources of computation and of storage, sometimes rendering it useless. Applications may be expecting data in particular schema, and some of the data sources or providers may not adhere to this schema. Examples could be date formats, abbreviations, audio or video formats. Even simple labeling variations in JSON files can cause some data analysis issues. So improper formatting can cause data analysis issues in addition to the storage and processing power that is wasted as well, adding more to the carbon emissions as well. When we come to the biased data, it can manifest as incomplete data due to either neglect or intent, because biased data may lead to incorrect results. It can have adverse impact on society at large and may even result in a threat to life. An example could be having, for example, a population sample that is not properly randomized. This means the sample isn't representative. It doesn't truly reflect the analyzed population. The main challenge here is the complex process of detecting the bias. If it is intentionally introduced, and once data has become biased, it is largely impractical to make it useful anymore. And then the last type I'm going to cover here is the data that is yet to be discovered. And it includes two subcategories in the paper. The first category represents the data that is out there but never collected or utilized. And it represents a missed opportunity to make good use of the data that is present but ignored, to be recorded or used to improve business operations. The second category is where data values or records are misplaced and are never identified as valuable. So it represents an unintentional mistake or ignorance of the utility of data that is already there. It causes, of course, wasted resources and collecting data, which never leads to any meaningful use of that data. So this happens either because of the lack of awareness on how to use this data that has already been collected, or because of the legal or other restrictions on their usage, like HR documents, personal finances, etc. And here I end by a simple example showing the impact of data that is yet to be discovered. It can be illustrated in the 1936 US presidential elections, where there's a popular magazine, Literally Digest, had previously successfully predicted winners of the elections. And in 1936, it predicted that the Republican candidate Landon would win. However, Roosevelt, the Democratic candidate, won the election. And it was discovered that those who failed to participate in the election polls were overwhelmingly supporters of Roosevelt and were mainly responsible for the faulty prediction. So like they sent 10 million cards out there, and around 2.4 million were returned for response. So the response rate was around 25% only, or 24%. So this was an example of how data yet to be discovered caused incorrect values when the prediction was actually wrong. I will stop here for my part, and I will now lead the floor to my colleague Guncha to continue with you on the impact of the dark data and how we can prevent and transform them to be useful to the organization. So the floor is now yours, Guncha.
Thank you, Oriette. So if you look at the impacts of dark data, there are five categories where I would like to bring the focus of this audience. The first is the data usage. When the organizations collect data, generally the data goes through the transformation, the extraction, transformation, and loading pipelines. But some data may be excluded from these pipelines. The data that is excluded from these pipelines run the risk of becoming dark. A quick check. Am I audible to anyone?
Sorry, Guncha?
Urjit, are you able to hear me? I'm getting a message that I'm muted. Are you able to hear me well?
Yeah, I'm able to hear you, yes.
Sorry about that. Okay. So the data that is excluded from these pipelines then have the risk of running dark. And that is where we need to bring our focus on. In their articles, Professor Tom Jackson and Ian R. Hodgkinson from the Loughborough University, they had cited that more than half of the data that the organizations collect are for single-use purpose only. In another study, Splunk had noted that the global average of dark data that organizations have is about 60%. The accuracy of the data is as good as the data accuracy of the data itself. Organizations need to determine what is the critical and pertinent data that is useful for their business requirements. For example, if you look at applications like knowledge graphs or large language models, they could work with the mildly curated data. The accuracy is not so important in these cases. But if we look at applications of e-commerce and payment data, that is where the data accuracy and the trustworthiness is crucial. If we look at the OpenAI's ChatGPT, this has been trained with around 300 billion words, which has been basically scraped from the internet based on the data that has been accessible to the system. But this has led to a large amount of misinformation. The ChatGPT output cannot be trusted because the source of the knowledge itself cannot be trusted. The transformed data is trustworthy to an extent to an extent because it is curated based on the lines that we want to use it for the business purposes. If you look at the large language models, they preclude the trustworthiness of the data, and that is in exchange of the data accessibility for the amount of training it requires. Organizations generally have explicit and implicit models of trust based on the governance and privacy models they have in place. The storage of the data can be done by the organizations on premises or on a co-location site or completely over cloud. The cost associated with this stored data is relative to the persistence and accessibility availability of the data. Implications of storage, of the storage array, the infrastructure, power consumption, the material consumption, thermal management, and other considerations need to be taken as an aspect when the cost of the storage of the data has to be associated. If we just take examples of hard disk drives and solid state drives, the power consumption by these two drives have a differing value of 6%. Now, if we scale this 6% value to a large set of data that we have, for example, gigabytes of data that may reside in the large data lakes, this impact is significant for the organizations. Measurement of dark data impact is in its very nascent stage at this moment, but as the organizations are refining their own telemetry and points of measurement, the measurement of data itself is rapidly increasing. In 2020, Veritas Technologies had published a study which had projected about 6.4 million tons of carbon dioxide being pumped into the environment because of the presence of dark data. Climate IQ, ClimateIQ.io is another website which provides interesting insights, which highlights the ecological costs due to the presence of dark data infrastructures like data centers. Before we start looking at the transformation and prevention of dark data, it is important to understand the data lifecycle itself. While this is not a true data life cycle, since data is always generated, this is a cycle where different phases of the data have been called out. And we'll take a look at how data transformation and prevention activities could occur in these stages. The create phase itself is one where the data is created or modified. This is the phase where the data classification and labeling methods will help the organization to discover the data using different tools. The store phase is when the data is stored. Store and archive are the two stages where we generally find the presence of dark data. Once the data is being processed, it gets into the use phase, and when it is shared with the third-party vendors, it is in the share phase. Now, in this phase, of course, the organizations would have to ensure that they are meeting all the regulatory requirements and legal requirements before the data is shared. The data that is dark, which is stored generally in the store and archive phase, they could be brought back to the use and share phase for the transformation. But the activity of prevention really occurs at all of these phases. Once the data is past its shelf life, it is destroyed or deleted in the destroyed phase. The transformation and prevention is like any other optimization business challenge that we have, and we could use the people, process, and technology framework to handle this as well. If we take a look at the people, process, and technology, on the people front, considering the kind of advantage that organizations get with the dark data itself, they need to align the talent management system to a data-centric business model that supports uh, that supports the prevention and transformation of dark data. They could do this by having some best practices implemented. They could have these data-centric roles like chief data officer, chief privacy officer, governance or officer in place. They could have trainings aligned to the specific roles like sustainability engineer, data engineers, AI analysts. There needs to be a awareness program generated for curated to the employees, curated for the employees, so that they understand the importance of avoiding any dark data and only retaining it for the required period. Uh, the leaders themselves could have conversations with their staff on the importance of dark data and have all the discussions, business results discussed based on the data itself. The process transformation is basically required because a clear, concise, and a well-defined process can prevent dark data. The controls and the governance that we need to put together in order to ensure that there is no dark data that gets accumulated also needs to consider that we are catering to the local and global standards for regulatory requirements. There can be a joint data governance and sustainability ethics board that can be formed to look at the metrics of the dark data itself. The the technologies that can be used, technology is going to play a key role in terms of transforming the dark data or even gaining insights out of the data itself, which is not dark yet. Um, when the data is created, having the data classification done using the tools rather than doing it via laborious manual efforts is crucial. We could use the metadata labeling tools, and we could also use queries like NoSQL queries on data lakes, large data lakes, to generate the results out of the unstructured data that may reside there. The natural language processing techniques will help us to discover the words and make connections between these words and statements to identify the patterns that are of interest. Since we are looking at data coming from different sources, which may essentially have the same type of data, the same content, but having different metadata or different field names associated with them, it is important to perform data mapping across those different sources so that we can stitch them together and aggregate them in order to get better insights. The dark analytics comprises of looking at the videos, the images, the patterns within that to identify the uh, uh, important metadata that may be relevant for the business organization and perform some analytics based on that. Languages like R and Python provide libraries that can be used for modeling and visualization. And there are open source tools, for example, Apache Spark, that can be used for classification, regression, and clustering of the data. And there are other tools like Jupyter Notebook, which can be used for the visualization itself. This can be then further used for the analysis by the humans. Oriette has already taken you through the different types of dark data that we have focused in this paper. What we would do here is look at how we could process this data to take the corrective actions and transform that data for further insights. So protected data is essentially overprotected or unprotected data, and of course, they have the risk of falling into the wrong hands or being completely unusable because of the amount of protection applied to it. In such a case, it is important to make sure that access controls are in place and are given the access is given only on the need basis. There are other technologies like homomorphic cryptography that can be used in order to make sure that the processes that need to look at the data, read the data, and process it can still do it without without anyone having the access to that data. The expired data um, the expired data is, of course, unusable data, but when the data is created, it is important to assign an expiry date to it. Without an expiry date, the data is either irrelevant or and definitely may lead to inaccurate results, leading to inaccurate decisions and impact to business. So if we look at any data, we need the data controller working in collaboration with the data custodian to ensure that expiry date is assigned to that data. Data expiry can have different values. It could range from 20 years to 20 days, depending upon the kind of data that is. For example, if there's a medical study being conducted over a period of 20 years, the data for all the 20 years need to be maintained and probably further in case someone wants to come back and review the results and explore further whether those results are accurate or not. But if we are looking at data related to a medical examination conducted for, say, cold and cough, that data will not be required for more than 20 days for sure. So, considering it is important that the data controller has a good context of the data requirement. We also look at the regulatory requirements here before any expiry date is assigned. The unlabeled data is essentially a data that cannot be discovered by the tools. We can, of course, have humans go in and look at the data to identify whether it is relevant or not and what is the purpose of that data. But having a laborious manual effort is quite challenging considering the amount of terabytes or petabytes of data we might have in the system. Automated tools like AI-based tools can be employed in these cases. The AI tools also could take a look at the unstructured data to identify the context, the patterns, and assign certain labels based on the matching text matching scheme. The incomplete data, the incomplete data and the incorrect data both may um, both may be introduced because of the incorrect checks or incomplete checks at the collection source itself. Or it could be because of the limited data that the source is sending over to the system where the data is being compiled. The incomplete data uh, for the incomplete data, we would need to understand the different patterns and the specific fields that are missing. These could be regenerated using some AI tools as well, based on the patterns that we have identified. Or we could decide that, for example, if we have um if we have a series of data for a particular time, and only for the small 3 minute period there is some data missing, we could have the data generated, predicted based on the prior and the post data. The incorrect data is really related to the the incorrect metadata labeling as well. This can be corrected based on the reference data dictionaries that we have. The field values themselves could be incorrect. For example, if we are looking for a range of values on a particular field, instead of being in that range, if the value is outside, it is obvious that the field value is incorrect. In such cases, we could have the AI-based tools, again, looking at the required data, or some manual correction can be made by the humans looking at the reference dictionaries. The improperly represented data is the formatting errors that may occur in the data. For example, the date format may be different when we are looking at data coming from different sources. These can be easily identified by the tools and corrected as well. Biased data is introduced because could be because of the limited test data used for training the models, or it can be because of the incomplete or very limited tests that have been used in the test data itself. These can be corrected by keeping into consideration various ethnicities, geographies, from the background of all the ethnicities and geographies from where the data is being collected, the income brackets, multiple regions, political affiliations. All these can be considered when the test data is being created. Also, when the data is free of all the biases, that is when we will have the accurate results from that. The yet to be discovered data is hidden data, and that cannot be corrected unless we really transform them by applying the right classification and labeling methods there. Once we have the right technologies and tools and the right skill sets employed, we can have the data discovered and used for the analysis. Um, we'll come to the conclusion of the white paper that we presented here. In short, we have talked about the data remediation itself, which includes the replacement, modification, cleansing, and deletion of the useless data. The data remediation itself helps the organizations to reduce their carbon footprint. It also helps the organizations to protect their critical data from falling into the wrong hands by employing the right protection and access control mechanisms. It also helps the organizations to find ways of identifying critical insights which are helpful for the business and unlock its full value. The best practices to eliminate the dark data are to put in place the right talent, the right processes, and the right tools. The dark data prevention and transformation help the organization in achieving the sustainability goals. It also helps the organization realize the benefits across all the organizations by putting together, stitching together the data from different organizations and bringing more value to the employees. And this data, the data can also be used for business results by employing, gaining good insights that can be converted into strategy and business outcome. With that, I end the presentation here, and I will hand over to David.
Thank you both, and good morning, good afternoon, everyone. It's a quick introduction to myself. I'm Dr. David McKee. I'm the CTO at Slingshot Simulations and chair of various working groups within OMG. So I'm going to look at some steps, practical steps, how we're considering you can handle get a grip on and understand the dark data estate. Really just getting a bit more practical off the great introduction we've just already had. But I would like to just pause for a second and start with just reinforcing Why is this so important? We've heard a lot about the impact on businesses and so forth, but let me give kind of a few key factors here. Is one, from a cost perspective, data being stored as a business, you're paying to store that data. And if that is 60, 70, 80, 90% of the storage you're paying for, that could be an awful lot that you're paying for in AWS, Azure, OneDrive, you name it. That data storage contributes to carbon emissions every year as well. So that would be part of your emissions that you need to consider as your business, and it's unnecessary. And of course, we've touched on some of the other value, the frustrations that we've all been in. How many times have we recreated spreadsheets where actually we just couldn't find it before, and we're wasting time doing that, wasting time not being able to share information. So if we can get a handle on these things, the implications can be huge and really, really positive for us all. So from a Slingshot simulation perspective, we look at handling dark data with 3 key steps: discovery, cleanup, and utilization. So where is the data? How can we find it so we can then do something about it? What do we do to clean it up? And then how do we create value from that data easily? And these are some practical steps that I would just advise to take on board and think about how you might be able to apply them. In terms of discovery, there's 2 things that we particularly look at. First of all, we look across 3 dimensions. We look at what is data talking about. Is it talking about, might be warehouse orders, products. It could be travel information. It could be sales information. What is the context? What is it talking about? And how does it relate to other things in your business and your daily lives? Is it relating to things that are spatial? Does it relate to places where your business might operate, whether it is the location of your clients, whether it is sites, warehouses, you name it? And then the temporal dimension, time. When is it relating to? When was the data created? So that has a couple sub-dimensions to it. Is when was the data created? How long do we need to keep it for? And then the data itself, is it temporal? Is it referring to events? Might be orders. When did they happen? And how do we pull these together? Together, those 3 dimensions build a picture of how valuable that data is. But more interestingly than that, it also gives us an ability to actually look at how this data is related to each other. And one of the findings that we have found over the last 2 years looking at dark data is when you look at data in those 3 dimensions, context, spatial, and temporal, you can actually link data across your organization using a graph-based approach. So building a network, as you can see on the slides here, where your data sets might be each of these individual dots on the screen is a data set in one of our clients. And the lines in between the dots are the relationships between those files, between those different databases, between those different sources, saying actually there is a relationship between these. And identifying that there are relationships between these is indicative of value. It is indicative of usage. And conversely, everything that we see around the outside is indicative of inactivity, lack of use, and potentially a lack of value. So what we look at there is saying, actually, why are some of these files, some of these data sources, why are they not related to connected to anything? Do we still need them? Because if they're not connected and they're not being used, are they actually valuable? But the stuff that is highly connected to everything we're doing in this business is likely to be highly critical, and therefore we might actually want to have an extra backup of it just in case. So this is an interesting tool and a perspective, and very easy to pull together. Once we've got that, and we can use this approach to do cleanup. We can look at the data that is disconnected, these ones on the top of the screen, and say, actually, they're not connected to anything else. So can we just get rid of them? Or do we just need to do an audit of them? And then there might be small clusters of data that we see in the middle of the screen where there's a small cluster of data that's highly related. Maybe it was a project, but that project may have finished 5 years ago, 10 years ago. Do we still need the data? Or could we just have an audit report that summarizes it? What do we need? And this provides a really useful visual guide to diving into, explore, well, what does our dataverse ecosystem, the dark data ecosystem of our businesses look like? And that, you can apply this. I've applied this on my personal OneDrive as well. And it is horrifying how much junk one actually has on there. Then we get to looking at utilization. So in order to drive value, we look at these 3 steps. So we look at how do we build a structured data lakehouse to help bring structure and organization across the data ecosystem within your organization. So how do we go from, you have data that's in OneDrive, data in SharePoint, Google Drive, Dropbox, you have data lakes, you have databases. How do we actually pull it all together, not pulling it into one location, but knowing where it is, having that map, like we saw a couple of slides ago, understand where it is, understand the formats of that data, not adding another dimension there. So we're not talking about just context, space, and time, but also understand the format of that data. Is it image data? Is it JSON, spreadsheets, CSVs, XMLs? What is it? And therefore, once we understand what that is, we can then look at building processes to make sure we can address one of the remaining biggest challenges, which is the fact that data is often incompatible with other tooling throughout organizations. And we end up creating duplicates of that data because we're converting it between formats. But if we're able to build a picture of what format that data is in, and therefore a set of practices as to how we want to store data in the future, we can start to prune that process, optimize that process, and build in automation in some cases, build in best practices, so we can get over to the far right-hand side and start creating value from that data, be able to generate insights from sales, be able to work out, well, where should we be putting our sales reps? How many orders should we be placing next month? Because actually we now know because we've been able to put our data together. And at Slingshot, our particular hypothesis is to use graph-based approaches. In this case, we talk about knowledge graphs to layer on top of that and understand how data is pulled together. All right, I want to just leave it at that and leave plenty of time for questions. Conscious we've got about 15 minutes left, but really thinking about these three concepts: discovery data, building up that knowledge graph approach, making sure you clean it up. And I'll give one quick anecdote to that before I finish, and then utilizing it to create value. And the anecdote I want to finish with is a question that hopefully every single one of us can relate to. Is particularly those of us who have kids and family, is how many photos do you have on your phone of your kids? But what percentage of those photos are you ever going to look at again? Particularly when you might have taken 3 or 4 or maybe a dozen photos to try and get your kid to smile. How many of those are you going to actually look at? But do we go through and prune that? Do we go through and clean those out? Clean out the fact that we've got thousands of photos of our kids because it's so easy to do. That's just one example of data storage we're paying for. It's a very small example, not really at the enterprise level, but hopefully it's one that we can all relate to, and one that we're probably paying for. It might only be $10 a month that we're paying for storage, but we're still paying to store that data. And if we could even start with that small step, we can start addressing these challenges of dark data even in our personal lives. And I will finish there and say thank you very much.